All right, so pleasant good evening, everybody. Let's get on with business. We know we have a lot to do in a very short space of time, so without further ado, we're gonna dive into what we need to get done today. But before we get into that, a few quick reminders. Remember that next week the link is going to be changed, so try and visit the school between tomorrow and Friday, or Monday afternoon, or Monday morning. And as usual, as I said in the group, just send me a picture of your light blue class pass um as a view once photo to my DM, and then I'll send you that link. Some persons already have that link already. All right, so this link expires next week, so we can't use it again. We have to use a different one. Okay, so that's for that. And remember, effective next week, January 17th and 18th, we start my extra class. So I'll let you talk. We'll talk about that next week. Cause we need to start get some practicing, literal exam questions practice. All right, that's related to the topic that we're doing. Okay, and remember, as I said regarding the SBA, I'm going to start responding to some person might have messaged me and them think me ignore them. I haven't. It's just that I have a lot on my plate, and that's why I kind of prefer if I see you guys in person so I can give you my responses same time and send you off. I'm at the school every day, guys. Every single day I'm at the school. Mostly I'm there from 10 straight until 6 in the evening, 7 in the evening. Right. Except for our class days, I'm there until 7 o'clock in the evening. And I'm there right throughout the day, so I don't go anywhere. So once you come down there, you're most likely going to find me. All right, so let's take a few minutes out of your busy schedule and see if you can bring what you have to me physically. If you're unable to give it to me physically, then I'll try my very best to respond to you online. But I don't like giving instructions through voice note because, again, people still not get it. So I'd rather have you in person than that. So try see if you can get those introductions and method of data collection and get your questionnaire up and running. Let me see if we can get at least that part out of the way by the end of January. And then so February now you can look into getting into your analysis and your discussion. Once you hand out the questionnaires, and you do your survey, you do your experiment or whatever, the SBA pretty much done, just the last bits you're gonna have left. All right. So see if you can deal with that as quick and as possible. Okay. All right. So got those little notifications out of the way. Let's dive into.
Sorry, your mic is muted.
Thank you. All right. So everybody can see my screen, I'm assuming. All right. So let's see if I can rename. This was Monday's class, not so? So this is Monday. All right. Rename it. Good. So I need to look for Wednesday. So that would be maybe it's the 21st. That's what it is, maybe. The 15th. Could it be? Let's check the 15th and see what happens. Oh, it was the coordinate geometry. Okay. Right, I see that we were doing that, and I think I gave you the video, not true? I gave you the video to watch because we say okay, so we went through equation. Oh, and then I gave you the link to the video to say you can watch it and get a review. So we would have finished with that topic. All right, so that's done. All right, cool. So we did that whole rise over run thing already. Okay. All right. What did we do last class? Was it algebra that we did last class?
We did the
The last
distributive law.
The distributive law.
Yes, sir.
Okay. Did we start the topic of measurement? Did we start that topic? Okay, let me see here. So this was what we did last class, right? The distributive law. All right, cool. So we get that. So that was Monday's class. That's cool. And we completed consumer argument. So did we start the topic? Pardon me. Did we start the topic of measurement? I think we did start it sometime last year. We did pause on it. Somebody can remind me. Did we do something about the era?
Yes, sir. We started it last year before the hurricane.
Okay. How far? Can you remind me of how far we did reach? All right. All right. So I don't want to teach measurement tonight. I'm gonna teach it this evening already. Okay. So we're gonna start one new topic tonight then. Yeah, we're gonna start one new topic tonight. So we are going to start. I want to make sure that I don't leave out anything. So I did math fundamentals. We did coordinate geometry. We started measurement. We did consumer arithmetic, worded problems. And we're currently on algebra. Cool. We need to start a new topic tonight. So
sir, we haven't done the kind of angles, triangles and stuff.
also we haven't done triangles as yet. That would be measurement.
We only would have done like one simple example with the SS thing.
Okay.
We didn't go into
right.
anything else like circles and
Might as well finish. Might as well just finish
stuff.
it then. Yeah, might as well we just finish it. In a minute, so we just leave it out there then. Might as well we continue.
So
let me see if I can find that document.
Yeah.
That would have had to been maybe. Let me check this. Let me check this page here.
I have the date of September 29th.
Thank you. That's when we would have stopped it, right?
Yes, sir.
All right, let me see. October 21st of this, 21st, 26th, 26th. So maybe it would have been one of these.
No, it would have been sometime in October 13.
October 13th.
Yeah, September is way up.
Okay, October 13th. All right, let's check it. So this is going to be October 13th. Let's check all the way down here. October is the 10th, right? So this would have had to be. Okay, there it is. Must be this year. 13th of the 10th. Okay, here it is. So you guys are on spot, right? So let me see if we can quickly just do a run through of what we would have done. All of this control, right? So we would have started talking about, let me see if we can scroll through and see if everything looks familiar. So we would have started the topic of measurement. And we said that the objective is to concept surrounding areas of two-dimensional shapes and the volumes of solids and prisms. We looked at what is the area. We looked at the different shapes. We looked at the square. We run through that. We run through some formulas right here. All right, cool. We looked at perimeter. Okay. We looked at some reverse questions as well. All right. For those who are new and you're wondering where can you find this recording, it is titled Measurement on my channel. So if it's a case where you want to run back through what you're seeing on screen here, the recording is already posted. All right, so we went through rectangle. I'm looking at it. We went through triangles as well. We looked at areas and perimeters of composite shapes. We looked at that funny looking shape. All right, cool. So I'll go on. We looked at the triangle. We said that a triangle is a shape that's bounded by three straight sides. We looked at different types of triangles. We looked at the isosceles. We drew them. We looked at some other stuff, scalene. All right, cool. All right, then we looked at the right angle triangle. We looked at the half base times height, the Heron's formula. Boom. We come back the next class and we looked at isosceles triangle, the scalene, All right, cool. We looked at some questions, half base times height. We looked at some reverse questions as well. Enough things to do then, man. Cool, this is nice. We looked at the area of the triangle with 3 sides. We looked at the Heron's formula. So we looked at that. All right, we are going with yourself. Areas of triangle with 2 sides. Okay. All right, cool. Lovely. All right, so you said, oh, so that's what you were trying to say. We only looked at one example, no, so? All right, cool. No problem. No problem. So we're going to finish it up then. It doesn't make any sense if we just leave it there. All right, since as we're there, we can just tidy it up then. No problem. All right. Do you guys wish for me to go through, as a review, do you wish for me to go through another example of what you're seeing on screen here? Of the Heron's formula, or are you okay with that?
Go through another example, sir.
Okay. All right. So I'm going to do a quick little recap then. Okay. Let's zoom up here. All right. Here we go then. Lovely. All right. So the last time we looked at this topic then is we looked at the areas of triangles, right? Areas of triangles. This is a recap, guys. All right. Recap. So areas of triangles. And as we mentioned earlier before, we said that the areas of the triangles, or the types of triangles that we have, is the isosceles, the scalene, the equilateral, and the right angle. And the right angle triangle. All right. And so each of these triangles have their own formulas. All right. Now, there are 3 formulas that governs the triangles. We have this one, A is equal to half base times height. And that one is specifically for the right angle triangle. We looked at area is equal to the square root of S bracket S minus A, S minus B, S minus C, where the value of S is equal to A plus B plus C divided by 2. And this formula is for the scalene. Or it can be for the, well, it can be for the equilateral as well. But rarely do we ever ask you to find the area for equilateral triangle. All right. So this formula is for the scalene. And then now we have this formula, which is going to be A equals A times B times the sine of theta, A times B times the sine of the angle divided by 2. This formula is mainly used for the isosceles, and it's used also for the equilateral. All right, if you look at those. So each formula is used to represent a particular triangle. So depending on the triangle you're looking at, then you have to use the appropriate formula. Right? Now, just to show you, because sometimes I feel like when I tell you some things, guys, I feel like if I don't show you evidence, you don't believe me. So I want to show you something. Give me a sec. Where's Safari? Okay. All right. So here, I'm going to look for a CXC past paper, and I want to show you where the formulas are. I know that some of you know it's there already. But let's see here. Give me a sec. So I'm going to type in CSEC math past paper. And then CSEC math tutor will come up. That's his website. When you click on it, it brings you to a page that loads up all the past papers that have been done over the years. So now I'm just going to pick the most recent one, which so this was the May-June 2025. That was last year. I'm going to close this, and it's going to open the document. There it is. So that's the exam paper. Oops. Now, look now, guys. I'm scrolling. This is the instruction at the front. And then look at this. This is the list of formulas. And if you pay attention, look way down at the bottom. Do you see that thing here? Look at it. Areas of triangle. You see that? Right, you see them? So areas of triangle, you can see right here, it is saying that what? Area equals half base times height, where b is the length of the base and height is the perpendicular, h is the perpendicular height. You see the second one, area equals, area of triangle ABC is half AB sine theta. And then you see the Heron's formula right down there. So again, S open bracket S minus A, S minus B, S minus C, where S is equal to A plus B plus C divided by 2. So now that you see it on the exam paper, and that was May 2025, we can come back to this page here. So that's what we're discussing tonight. So to find the areas of these triangles, it depends on what triangle you have. All right, so let's refresh the page. Give me a sec. So a quick little example before we run through. Okay, somebody is saying that they can't enter the class. I'm not sure what's happening because the code is correct that you're using. So I'm in the waiting room and I don't see anybody in the waiting room. Okay. So I'm going to share my screen again. Here we go. All right, boom. Wonderful.
Sir, maybe the person is on the other link that you sent.
No, they don't have it.
Okay.
Yeah, because it was instructed in the room that we're using this link for this week. So okay. All right. So I'm going to go ahead, then I'm going to draw I'm going to draw a triangle, right? So here's a triangle that I have.
Sir, can you just slide back the page a little bit down? Let me get a pic.
Oh, you mean of everything?
Just the formula that you just write down.
Oh, all of them. Okay, there they are.
Yeah.
Finish?
Yes.
All right, good. All right, so here's recap question. Let's get into it. I'm going to put some measurements here. I'm going to put 4 centimeters here. I'm going to put 9 centimeters here. And I'm going to put 13 centimeter here. Let me just quickly check, see if this can work. That's 22, 26. I need a bigger side. Hold on. Let's do 15 here. 26 can't work. Let's do 20. Let's do 15 here, so that can work. 15. All right, and the triangle, the name of the triangle is going to be some random name. It doesn't matter. We're going to call this triangle XYZ. So looking at this triangle, the question is going to be asked you that you need to find the area of this triangle. So we have three formulas. We have half base times height. There's no height here. Remember that height has to be vertical or height can be horizontal. So there's no height here. And while you can assume that 15 might be the base, you can't use 4 as the height because one person can use 4 as the height. Another person can use 9 as the height. That's two different values. You're going to get two different answers. So you can't use half base times height. You can't use half AB times the sine of the angle because there is no angle present. So by process of elimination, you've eliminated formula 1 and formula 3. So you only have formula 2 to work with, which is the Heron's formula. So therefore, they will start out by saying area is equal to the square root of S bracket S minus A S minus B S minus C. So to use this formula, we first need to find S. S is equal to A plus B plus C divided by 2. So first thing we need is S. We know that A, B, and C are the sides. So that's A, this is B, and that's C. So let's add those together. 4 plus 9 plus 15 divided by 2. 4 plus 9 is 13. Oh, can this work though? I don't know. I don't think this can work. 4 plus 9 is 13, right? And 13 plus 15, that's 28. No, this can't work. I need to increase this side. Let's increase this side by, let me see, 28, 31. Let's increase this side to 30. Let's increase this side to, let me see, 4, 7, 9. Let's put this side to 11. Let's see if that can work. Give me a second, guys. Let me check it. 11 plus 15, that's going to give us 6. That's going to give us 26. 26 plus 9, that's going to give us 35. 17. Yes, let's put this as 12. Yeah. So that should work now. All right, here we go. So we have one side measuring 12, we have one side measuring 9, and we have another side measuring 15. So let's go ahead and plug those numbers in now. So A would be 12. B would be 9. And C would be 15 divided by 2. 12 plus 9, that looks like 21. And 21 plus 15, that sounds like 36.
36.
36 divided by 2 is 18. So that's our S value. Now, this is our S value. That means this 18 is going to go here. It's going to go here. And it's going to go here. And it's also going to go here as well. And we plug back the A, the B, and the C in the formula. So therefore, the final answer then is going to be A is equal to the square root of 18, open bracket, 18 minus 12, 18 minus 9, 18 plus 15. Sorry, 18 minus 15. My apologies, guys. And then we're going to divide. Yeah, sorry, not divide. That's it. So if you do the math, then we're going to end up then with the square root of 18. Bracket means to multiply. So that's 18 times. 18 minus 12 is 6. 18 minus 9 is 9. And 18 minus 15 is 3. We can then proceed now to go ahead and multiply 18 by 6 by 9 by 3. Can somebody confirm that answer for me, please?
2916.
I'm sorry, pardon me?
2916.
Flat? Okay, yeah, flat.
Yes, sir.
Go ahead and find the square root of that number now.
$54.
Flat?
Yes, sir.
So 54. Somebody's mic is unmuted. Please remember to manage your microphone. Somebody's mic is unmuted, please. Oh, hi, Abigail. Me just to see you join the class.
Thank you for adding me back, sir.
Oh, you were kicked out?
Yes, sir. I don't know what happened.
That's okay. You're back. We didn't go too far. All right, so we got 54 you said for the last answer, right? 54? All right, so that's basically it. That's where you find the area of the triangle. So you just need to do a little practice and you'll be okay. Now, what's the objective for tonight then? I don't want to spend too much time on the review. Tonight, we want to go through 3 more shapes. We want to go through the area of the parallelogram, the area of the trapezium, and the area and the circumference of a circle. Now, I don't want the class to finish without going through the circle. So I'm going to start with the circle and then end with the parallelogram and the trapezium. All right? So head up for me, guys, area of circle. Area and perimeter of a circle. So let me take you back to grade 5 or grade 4 when you would have been first introduced to the circle. Assuming that everyone in here knows what a circle looks like, a circle is round. That's my circle. Okay? And every circle has a center. Every circle has a center. Let me see if I can zoom up this a little bit. Hold on. Right, good. That's my circle. And every circle has a center. Now, the line that is drawn from the center, first of all, we label the center with the letter O. And the line that is drawn from the center to the circumference is known as your radius. We label that R. The line that is drawn through the center is known as the diameter. We label that one D. So in notation form then, I can drop a little notepad here. And we can say that the diameter is a line that is drawn through the center of the circle. And we can also state that the radius is a line that is drawn from the center of the circle. So we can save that little note right here. I'm going to come back to that document in a second. Let's move it to the side here. Let's move it down here. Yeah, put it down here. So the diameter is a line that's drawn through the center of the circle, and the radius is a line that is drawn from the center of the circle. I'm going to use a different color ink here. Let's use, doesn't matter. Let's use here. Now, we're going to talk about this later. So for now, this region right here, so that I shade in yellow, that's called your sector. We'll discuss more about that later. I'm just identifying it from now. So this yellow section here is known as the sector. So this is known as your sector. And then we have this section here. That I shade in blue. This is known as your segment. We'll talk about that and extend on it in our next era class. That's called your segment. I'm going to try to shift this over a little bit. All right, good. Yeah. So this is called your segment. And then now, around the edge of the circle, it's called your circumference. So around the edge right here, so coming right around like that. That the part that I've labeled with the broken line, the red broken line, is known as your circumference. All right, now there's a few things that you need to know about the circle in order to manage the calculations that are coming. There's a particular constant value that you need to be familiar with, and that constant value is known as pi. So going forward, pi has a constant value that we refer to as 3.142. And then also some instructions will require pi to be used as a fraction. So some instructional books or formula sheets will say pi is 22/7. That value does not change. So we're going to put that in a little box right here. So remember it. So remember that pi is 3.142. You can leave out the 2 if you want to. I like using 2. It gives me more accuracy. But if you leave out the 2, it's not going to change the price. All right. That's fine. So having known the value of pi, we also need to know that there's a relationship between the diameter and the radius. It's a very key relationship moving forward. Because later on, when we start to look at more advanced questions, we're going to look at the fact that the diameter and the radius has a relationship. So what's that relationship that they have? Let's go back to our notepad here. So we're going to drop an extra information in here. We're going to say that the radius and the diameter has a distinct relationship. That is, the radius is half the diameter. Well, let's write it better. The radius is half the length of the diameter. Or you can write it the other way, or you can say that the diameter doubles the length of the radius. Now, that's when you write it in words, but writing it in words won't help you, right? Writing it in words won't help you. We need to have an equation for it. So we can write it in shorthand. We can say R is equal to D divided by 2. Or the other way around, you can say D is equal to 2 times R. I'm going to put this in the box again. Those are some key information that we're going to need later on. So, I like how the box look at all. All right, good. So those information are going to be key when we start to do more advanced questions. So just keep an eye out for that. Now, from this, now we can move on to more structured formulas. All right. And so one of the first formula we're going to look at is, again, say here, the area of the circle. What exactly is that formula? So the area of a circle can be calculated by using the formula pi r squared. So the area of circle is equal to pi r squared. So it's pi times r squared. All right, I would just shorten it. I would just say A equals pi r squared. So I'm going to give you a quick little comfort, right? So we're going to grab our Safari here. We're going to go back to that past paper. I want to show you that it's on the past paper. So if we go back to the past paper here, look up at the top. Oh, it's not there. Then take it off. Oh, lie. There, them one. See it there. See there? Area of circle. A equals pi r squared, where r is the radius of the circle. So I don't know if that's good news or bad news. Or it's no news at all. It's up to you. That formula is given to you on the exam. And then the next formula that we need to know, and these are all base formulas that we need to know, the circumference formula. Now, circumference is the name given to the perimeter of a circle. Every other shape has a perimeter except for the circle. So we don't usually refer to the circle having a perimeter. We change from the word perimeter and we use the word circumference. But if you get a question that says calculate the perimeter of the... Pardon me?
Excuse me, sir. Someone is in the waiting room.
Okay, thanks. Why are these persons so late? All right, so circumference is equal to 2 pi r. So these two formulas are going to be formulas that will be key to answering future questions. All right, so area of a circle is pi r squared, circumference of a circle is 2 pi r. And as usual, I'm going to give you reverse questions as well. All right, so go ahead and I'm going to dictate a question to you, or should I type it? Should I type it, guys? Should I type the question? I think I should. What do you think? Type it or dictate it?
Type it, sir.
All right. So I'm going to type a couple of questions here that will allow us to apply the formula. All right. So question 1. Given that the radius of a circle is 9 centimeters, calculate the length. Given that the radius of a circle is 9 centimeters, calculate the length No. Calculate the following. The area of the circle, the circumference of the circle. A very basic question just to start us off, so you can get used to applying the formula. See that it's not that challenging. All right, let's grab that question and put it here. There. So we are given one single information here. We are told that the radius of the circle is 9. And we're being asked to find the area and the circumference of the circle. So very easy. Part 1, area equals pi r squared. So area is equal to 3.142 times the radius we're told is 9, and we're going to square that. So can somebody process that calculation on your calculator for me, please, and let me know what your answer is?
I'm getting 254,502. Somebody can confirm it. 254,502.
Me too.
So 2.254502, so 50 centimeters squared. And that's the area of the circle. So that answers that question. Circumference of the circle is 2 pi r. So circumference is equal to 2 times 3.142 times the radius is 9. Can somebody go ahead and process that calculation now?
Um, 56.556.
56.556.
Yes, sir. That's what I'm getting. Somebody can confirm.
So that's 56, right? So 56.56, yeah.
Okay.
Centimeter. All right. So as you can see, it's not very difficult to find the area of a circle or the circumference of a circle. Where the challenge comes in now is when we get a question that's in reverse and that requires interpretation. So I'm going to grab another notepad here and write question 2. Given that the area of a circle is 74 centimeters squared, calculate the diameter calculate the length of the circle's diameter. And hence find the circumference of that circle. So this is a reverse question that requires you to know how to apply the formula. Let's just zoom it down here. Boom, like that. So once again, the question kicks off here by talking about the area. So you have to start with a formula based on what they've given you. So they're giving you the area to start with. So you have to start the question by writing down area is equal to, pardon me guys, sorry. So we're going to start by saying area is equal to pi r squared. Now, over the years I'm teaching, I didn't really realize this, but I haven't paid attention to, like, when students are working out, what they tend to do is they tend to write down this part and forget to write down that part. So you can tell a student this 100 times and they'll get it. The area of a circle is pi r squared, but when you're doing the calculation, they forget to write down A equal pi r squared. Ladies and gentlemen, please do not forget to write down A equal pi r squared. I think we enunciate on this quite a bit. In our previous topic, I showed you a lot of reverse question that requires you to write down the actual formula. So you can't just write down that area of circle is just equal to pi r squared. If you write it down like that, you won't know where to put A. And it's not all the time they ask you for the area. For example, in this question, I gave you the area and I wanted to find the diameter. So when you're working questions like these, especially when it's not straightforward, and you're going to know when it's not straightforward, you know? Because when you write down the area formula and you realize that you don't have the radius, you're going to know it's a reverse question. You automatically are going to know. All right, so we start off by saying area equals pi r squared. Let's plug some numbers in now. Getting some free, guys. Hold on, give me a sec. All right, so here we go. So the area of the circle, or the area of a circle, is pi r squared. In this case, we are told that the area is 74, so we put the 74 underneath the letter A. We know that pi is 3.142. And in this case, we don't know what r is. And please bear in mind that we're not looking for the radius, we're looking for the diameter. But if you go back up here, we created a relationship between the diameter and the radius. See it up here, so? So we know that the diameter is going to be 2 times the radius. So that means we have to find the radius first and then double it to find the diameter. So that's why I gave you that relationship earlier. So if you go back down here, let's go ahead and find R. Now we need to isolate R. We need to get R by itself. So we need to remove the 3.142. Now, what's the relationship between 3.142 and R squared? What connects them? What sign connects them?
Multiplication.
What's opposite of multiply?
Divide.
And that's going to give us the value of R squared. All right, go ahead and process what is 74 divided by 3.142 for me, please.
That's 23.55.
Could you repeat that for me?
23.552.
552. So 55 is fine. And that's equal to R squared. Now, remember, we don't want R squared, we want R. So can anybody recall how to remove the square when it's attached to a letter?
Square root, sir.
The square root, very good. So we're going to square root the 23.55, and that will give us the value of R. Go ahead and square root that number for me, please.
$4.85.
Very good. Now we can draw the conclusion now. Therefore, the diameter is equal to 2R. So the diameter is going to be equal to 2 times 4.85. And that's going to be equal to 9.7. Confirm that, please.
Yes, sir.
All right, good. Now the question went on to say, hence, find the circumference of the circle. So hence means now, as a result of the calculation that was just done, use that information to help you to find the circumference. So circumference, therefore, is going to be equal to 2 pi r. So in this case, now we're looking for C. And that's going to be 2 times pi. And guess what happened? We just find R right here. So that's going to be times 4.85. Go ahead and process that for me. 2 times 3.14, 2 times 4.85. I'm waiting for the answer now, guys. I don't have a calculator working with me.
30.48.
30.48 centimeter. And that's it. So that's an example where you find the area of the circle and the circumference of a circle. And that's also another example where you can get a reverse question where you're given the area and you're asked to find the radius or the diameter in reverse form. All right. Now there's much more complicated questions, right, which will come in due time. As I said, you're going to see these questions in our extra class or in our marathons coming up. So you're going to see them. I'm just giving you a basis from which to spring from. Now we're going to look at 2 more concepts, right? Remember, guys, I'm just touching base on the fundamentals. But that's why you see how to apply the formula. Now we're going to touch base on something known as the sector and the arc. All right? I'm going to touch base on that. So we're going to look at a concept known as the sector. The sector and we're going to look at the arc length. All right. Now, what I normally do to get this concept across to my students over the years is I ask them to visualize a pizza. Right? And so for the sector, as simple as I can put this, the sector is a slice of pizza. So here's what we're going to do. We're going to draw a circle and let this circle represent a pizza. That's the circle. Right? And every circle, let me just zoom this up a little bit for you. Every circle, as I said, has a center. That's the center. Now, look on this now. If I take a knife, right? A knife or a pizza cutter, and I cut the pizza this way, and then I cut another slice right here. This is the center of the pizza. We're going to call it O. This is the edge of the pizza. That's A, that's B. This section right here, ladies and gentlemen, is known as your minor sector. And the remaining portion is called your major sector. All right. So that's what we call the sector. So basically, what helped me in teaching and when I was learning this, my teacher referred to the sector as a slice of pizza. So if you know what a slice of pizza looks like, then you know what a sector looks like. I'm going to slide over here then. And I'm going to draw a circle once more. And this time now, I'm going to show you what the length or the arc is. So watch this now. Let me zoom up. Around the edge, sorry, wait, hold on. So now I'm going to put another center right here. I'm going to draw another arc. I'm not going to draw another line here. That's the radius. I'm going to draw, this is center O. I'm going to draw another line here. That's another radius. So both of them together are called a radii. Now, this section right here, so ladies and gentlemen, from this point right here, we're going to call this point A again. We're going to call this B. This section right here, so guys, is what we call the arc. That's the arc. That portion of the circumference is called the arc. So this is called your minor arc. And this is called your, the rest of it, let me just put a different color. The rest of it is called your major arc. And if we zoom on now, we can see the difference between the two. So basically, if you can envision the crust of the pizza, the crispy part around the edge of the pizza, that's called your arc. And the meaty part of the pizza is called the sector. Now, I'm going to drop a little notepad here, give you some notes. So, here's some notes. Both the sector and the arc represents a fraction of the circle's area and circumference, respectively. So what does this mean? Let's drop it in the middle right here. Zoom up. Code. Here we go. So both the sector and the arc represents a fraction of the circle's area and circumference. So what this means is that the sector is a fraction of the area and the arc is a fraction of the circumference. So when we say fraction, we mean a piece, a portion, a certain amount of it. It's not the complete total, it's a piece of it. Now again, I'm going to go back to Safari because I want you to see that a lot of these formulas, you don't necessarily have to study them. So if I grab Safari here, and the formula pops up on the screen, if you go to the formula sheet, guys, look at that. Arc length. You see that right there? So, see there? Arc length. That formula is given to you. There it is right there. S equals theta over 360 times 2 pi r. And they also give you, guess what happened? The area of the sector, which is going to be what? Theta over 360 times pi r squared. So you might be asking, then sir, what an ugly looking symbol here, that little zero with one line between it. That symbol is called theta. And that symbol is what we use to represent an unknown angle in mathematics. So where would we find that angle? Where would that angle come from? Would they give it to us? Of course they're going to give it to us. They're going to give you the angle. So let me show you where you can locate that angle. It's loading, guys. Give me a minute. So here, the formula for the area of a sector, as seen on the past paper, is theta over 360 times pi r squared, right? And then say A equals. So don't forget to write that A equal, all right? So depending on if you get a reverse question, you might need that A equal, all right? And then over here now, them say S, which S is what they use to represent the arc length. I don't know why them do that. I would have just written L. I now follow them still. I gotta just use L. I want to throw you off. So L is going to be equal to theta over 360 times two pi r. So remember, don't confuse them, you know. One of them is pi r squared and the other one is 2 pi r. All right. So you were asking, or I'm assuming that you're asking, sir, this symbol right here, I don't see it on the diagram you just draw. Where do we find where do we find that symbol? So that symbol is going to be right here. Ouch. So that symbol is going to be right here, guys. So that's where we have theta. And that's the theta we use when we want to find the minor arc or the minor sector. But sometimes they'll ask it for the major, so watch out. Watch out, guys, watch out. Because when the questions are structured, the structure kind of funny, so be careful. Because there's also a theta around here as well. So that's for the major. So this could also be theta as well. I'm going to call it alpha. So just be mindful. Let me just draw it with a different color. I don't want to confuse you. All right, good. So around here could be a theta as well. But that's only if they want you to find this portion of the line. All right, that's only if they want you to do that. But we'll talk about it shortly if we get the time. So again, majority of the time you're going to find theta right here. That's where theta is, right there in the center. And that angle is always going to be given. All right, let's do a question. That makes the center give you the formula and then you're not seeing how it's applied. So let's go ahead and try a question. Let's grab another notepad here. And this time I'm going to draw a diagram that's associated with the question, okay? The diagram below, not drawn to scale, represents a circle. The diagram below, not drawn to scale, represents a circle with center O and radius 9 centimeter, or radius 7 centimeter. Using this information, calculate the area of POQ. I'm going to show you what POQ is. Calculate the area of POQ and the length of PRQ. All right, so question look vague until we draw the diagram for you. Let me draw the diagram that represents the one in pink. So that's the question right here. And this is the diagram that represents the question. I don't like that. So this is the center. That's O. This is P. This is Q. And this is R up here somewhere. And then say this is 9. And 9 is R7. Oh, 7. All right, so that's the diagram that represents information. I'm going to zoom out now. Here we go. So that's the question, and that's the diagram that matches the question. Let me move the question a little closer, like so. Right. Yeah. So we are looking at this diagram, right? And the center is labeled O, and there are 3 points on the circumference P, Q, and R. It says the diagram, but it should have said the diagram below. But it says the diagram not drawn to scale represents a circle with center O, which you can clearly see, and the radius is 7. You have to use this information to calculate the area of POQ. Let me just shade that in red. So what they wanted to find is the area of this shape right here. In the study, what you find. And then I'm going to use a different color ink now, like green. Then say for part 2, so this is a calculate the area of POQ, that's that part. And then say they want you to find the, this should have said the length. Oh my, I'm sorry. It should have said the length. So it says use the information to calculate the area of POQ and the length. My bad, guys. Sorry. The length of PRQ. So where's the length of PRQ? So what you're asking for is this length right here. Let me zoom up. Get a little bit closer. So what they want is the distance from here, pass through R, and come back all the way around Q. So they want the length of that piece, and they want the area of the red portion. So this question is a clear indication that if you're looking for them to write, I mean, I'm not saying that they won't or they can't or they will not. Don't expect them to write down the question, find the area of the sector or find the area of the arc. They'll just use the letters, and then you have to determine what kind of shape or what part of the circle does this part represent. So the red section that I've shaded there, you can clearly see that represents a piece of the pizza, right? It's like a slice of pizza. And as we said earlier, if you were to zoom up here and go back to your notes, you'll realize that that section there is actually a sector. Specifically, it's the minor sector. So that will require us to then grab the formula for the area of a sector.
Excuse me, sir.
Yes.
I'm gonna log out now because I'm leaving work.
All right. Okay.
Okay, thanks. Good night.
Good night. Good night. All right. So quickly, because time's almost up. Let's go ahead and find the area of that POQ, and we can agree all together that POQ is a minor sector. So therefore, area of the sector is going to be equal to theta over 360 times pi r squared. So theta, oh, I did, guys, I couldn't tell me I'm not giving a theta. I have to give you theta, you know. Never see I'm not give you theta. Oh, Lord. I'm going to put theta here as 1. I'm going to put theta here as 80 degrees. Yeah. So I'm going to put the angle right here. I'm going to call it 80 degrees. Okay, my apologies, guys. Sorry. All right, so area is going to be equal to 80 divided by 360 times 3.142. I could use 22 over 7, you know, but I'm still going to use my calculator, so it doesn't matter. So I'm going to go ahead and use pi as 3.142. The radius is 7, and I'm going to square that. So go ahead and process that calculation for me, guys. 80 divided by 360 times 3.142 times 7 squared.
I'm getting 34.212, and the number continues 8889.
How much you got? 31 point?
34.212.
So I'll work with 2-1. That's fine.
Okay, right.
That's it.
Yes, sir.
So the area of that red shaded portion there is 34.21. So that's how you find the area of that portion of the circle. Now for the last question then now, right? Now when I tricky now enough, so if you don't know what you do, you might make a mistake. It's pretty easy when you listen to working out, for the interpretation. Now the next part or the last part says that we should calculate, let's see here, says that we should calculate the length of PRQ. So look at that green part that I've labeled. That green part, that big edge of the circle there, is not the complete circle, It's from P, past R, and come back around to Q. So that means we leave out that portion here. So it's not the full circumference we're finding. We're finding a portion of the circumference. What is that portion called? The arc. So length of arc is going to be equal to theta over 360 times 2 pi r. So we're grabbing this formula up here, that one. So length is going to be equal to, all right, watch now. What is theta? Anybody guess what is theta?
The 80 degrees.
That would be 80, take 80 from 360.
Excellent. Second answer is right. So 80 would be the degree that we'd use if we were finding PQ. Because we're finding the big cross, the big edge, you need a big angle, which is the one out here. So that's what I was trying to explain, or that's what I was trying to bring across when I was over here. When I was explaining this up here, I was saying to you, be very mindful of the what? The angle. So you have to know whether you're finding the minor or the major, because if you're finding something major, you need a major angle. If you're finding something minor, you need a minor angle. So in this case here, this theta will not be 80. It's going to actually, theta in this case is going to be 360 minus 80, which in this case is going to be 280 degrees. So that's the trick in this question. All right. So the length is going to be equal to 280 divided by 360 multiplied by 2 times 3.142 times 7. All right, could you go ahead and process that calculation for me, please?
I'm getting 34.212.
No, sir. Can't be same.
What am I wrong? What am I wrong?
Check again.
280 divided by 360 times 2 times. Oh, I see what happened. All right, let me recalculate.
34.21.
How much you got?
34.21.
24?
4.
I'm sorry, you're echoing. I'm not hearing you.
34.21.
I see anything we get over here, sir?
Yeah.
That is interesting. I've never seen that before.
But that's what I'm getting to, right?
Oh, well, I first never see the area and the circumference being the same thing. Oh, maybe because I use the number 7, that's why.
Yeah.
When I use numbers like 7 and 14 and 21, it normally come out like that. All right, so 34. Somebody's mic is unmuted. Please remember that. Your information will go out into the media. So 34.21 centimeter. Remember, so 1 centimeter squared and 1 centimeter, because one is length and one is area. All right. All right, so guys, remember that this is just an introduction, as I said. It's just an introduction just to get you to see the formula and how it's applied, and it's not that complicated. But remember that there are more advanced, tricky questions that we will have to practice as a group. All right? I don't want to trick you until I say, oh, yeah, man, this is all that it takes. No, it's a lot deeper than that. It's a lot trickier than that. But it's going to come with experience and with explanation. But the objective for the class was to get you to understand these formulas and how they're applied and how you identify these particular shapes. All right? So we're going to look at some of the questions next week. I'm going to come with maybe like 2 or 3 advanced questions that intertwines the circle with another shape. We're going to look at some what you call composite shapes. So I'm going to come with a couple of questions next week, right? We're going to kickstart the first half an hour of the class with 2 advanced questions that requires the usage of these formulas. So that's for next week, that's for next week, Wednesday. All right? Yeah, and remember, we don't have class this Sunday. All right? Please note, we don't have class this Sunday. It's effective the other week. We're going to start doing that. Okay? All right. So it's 8:32. We have passed our time. And that brings us to the end of tonight's session. You can access both recordings for this week tomorrow evening at 7 p.m. All right? So I'm going to post them from tonight on Premiere and have them released. So you can watch them if needs be. All right, have yourself a good night. Be blessed. Have a safe weekend. Good night.
Thank you. Same to you,
Nice,
sir.
sir.
Good night, sir. You too.
Good night, sir.
Antonila, no, I won't be having class this Sunday. Good night, Sasa. Good night, Galia.